Hi, my name is Shahroz Ahmed, and in this video I'm going to discuss a topic of differential equations, and the topic is the first order differential equations. So let me just tell you first what are the first order differential equations. So basically the differential equations having only one derivative, they are called the first order differential equations. I'll write it here. The equations having only the first derivative they are called the differential equations. They are called the first order differential equations. For example, if we have an equation like dy by dx plus 5xy equals to 6x. So in this equation, as we can see, that we have only one derivative, and that's the first derivative. Or we can write it as y prime minus 7x equals to 9x squared y. Over here you can see in this equation we can see only the first derivative. There is no second derivative. So such differential equations are called the first order differential equations. Now there are several ways to solve the differential equations, and I'll just list down the possible ways that by which we can solve the differential equations. But over here we are going to do we will gonna solve the differential equations by only the two methods. So the methods for solving the differential equations. So mainly there are four ways to solve the differential equations. There are basically four ways by which we can solve the differential equations. Number one, we can solve the separable equations in a simplest manner. Separable equations. These equations are very easy to solve. The next one is basically the homogeneous method. We can solve the first order differential equations by the homogeneous method. The third way is the integrating factor. And the fourth way by which we can solve the first order differential equation is the exact differential equations. So we make the differential equations to be the exact differential equations, and then we can solve it by using the technique of separable equations. Alright, so over here right now we are going to solve the separable equation. So I'm going to write down a separable equation, and then we will see how we can solve it. Alright, so now I'm going to solve a separable equation. So let's see how we can solve the separable equation. So here we have an example: y prime plus 2xy equals to x. So this y prime can be written as dy by dx, so plus 2xy equals to x. So we can write dy equals to x minus 2xy times dx, and now we can take x common from here, so it will become dy will become equal to x times 1 minus 2y times dx. Now I'll bring this 1 minus 2y onto the left side, so I'll have 1 over 1 minus 2y dy equals to x dx. So now first of all, in the separable equations we have to separate the variables. We have to write the variables of y with dy and the variables of x with the variable x with x. Now we can take the integral on both sides. So we'll take the integral on both sides. So in order to solve the right side, it's quite simple. It's like x squared over 2 plus the constant, but on the left side we have to use the method of substitution. So for that purpose I will say that let u is equal to 1 minus 2y, so du over dy is equal to minus 2, so that dy will become equal to du over minus 2. So in place of dy I will insert du over minus 2. In place of 1 minus 2y I will insert u. So it will become integration of 1 over u times du over minus 2. So I'll keep it separate. I'll start working from here. So the integration of 1 over u will become equal to ln u, and this minus 2 will be written separately outside the integral sign. So I can write it as minus 1 over 2 integration of 1 over u du equals to x squared over 2 plus constant. So it's like minus 1 over 2 ln u equals to x over 2 x squared over 2 plus constant. Now I'll put back the value of u because I have integrated it, so it'll become 1 over 2 ln 1 minus 2y equals to x squared over 2 plus constant. This 2 will get cancelled, and I will get ln 1 minus 2y equals to minus x squared plus constant. Now I will take the antilog on both sides. So on the left side I will get 1 minus 2y, 1 minus 2y equals to e to the power of negative x squared plus c. So this negative x squared plus c can be written as c e to the power of negative x squared, and on the left side I will have 1 minus 2y. Now I have to make y as my subject, so minus 2y is equal to c e to the power of negative x squared minus 1. Now I'll divide both sides by negative 2. Negative 2, this will get cancelled, and I will get y equals to c e to the power of negative x squared minus 1 over minus 2. So this minus can be written, okay, that's fine, I think. So this will be our final equation. So this is how we can solve the separable equations. Alright, so after the separable equations, we will have to discuss the homogeneous method of solving the first order differential equations. So the homogeneous method. In this method, I'm going to write down a differential equation that cannot be separable. So let's see how we can solve that. So the equation is dy by dx equals to x squared plus y squared over xy. So we cannot separate this equation. So first of all, what we have to do is we will have to divide the numerator and denominator by x squared. So it will become x squared plus y squared whole divided by x squared. Similarly, we'll divide the denominator as xy over x squared. So in the numerator we will get 1 plus y squared over x squared divided by y over x. Now you can see we have made a form of equation. So in this one, this is y over x. So in place of y over x, we will substitute v. So we'll say let, over here I'll do the working. So we'll say let v is equal to y over x, so that y is equal to vx, and dy by dx will be equal to, we'll apply the product rule over here. So product rule means the derivative of the first one times the second one. So the derivative of the first one times the second one plus the first one as it is, and the derivative of the second one, that is 1. So it will become dy by dx will become equal to dv by dx times x plus v. Now in this equation we will put v equals to y over x. So it will become 1 plus v squared divided by v. Now we can equate these two equations with each other. This is dy by dx, this equation is also dy by dx. We will equate them with each other so that 1 plus v squared over v will become equal to dv by dx times x plus v. Now on the left side it will become 1 over v plus v equals to dv by dx times x plus v. These two v's will get cancelled, and I will have 1 over v equals to dv over dx times x. Now I'll separate the variables. So on the left side I will have 1 over x dx. On the right side I will have v dv. Now I'll integrate both sides. So on the left side I'll get ln x plus the constant. On the right side I will get v square over 2. Now I will insert back the value of v, that was y over x. So ln x plus c is equal to 1 over 2 times y over x whole square. I'll take this 2 to the left side, so it will become 2 ln x plus c equals to y over x whole square. I'll take the square root on both sides. So once I take the square root, I'll do the working over here. So this square will get cancelled with the square root, so that y over x will become equal to plus minus under root 2 ln x plus c. Now I'll multiply both sides by x, so that y will become equal to plus minus x under root 2 ln x plus c. So this will be my answer for the equations that cannot be separable, and we have got this answer by the homogeneous method. So this is it for the part of the first order differential equations, and I hope you understood the video. So thank you so much for watching.